A lot of race motor builders choose to run needle roller bearings where space is limited but high load capacities are needed.
I'm Pat Courtney with JTech, and today we're going to talk about drawn cup needle roller bearings. So, drawn cup needle roller bearings is basically a drawn cup. Unlike the other ball and roller type product and some of the other needle product, it does not have an inner ring. So it's got to have this outer cup, which is like an outer ring, and then it'll have rollers. In this case, it's got a rollers and cage, and sometimes it doesn't even have a cage. So it's going to have just a full complement of rollers. So as opposed to a cage and roller, which looks something like that, where there's a cage separating the rollers. But no integral inner ring. So just the cup, the rollers, or the cup, the rollers, and the cage. Now, what is this cup? So what is a drawn cup? Well, drawn cup is basically we take a thin sheet of steel and we draw it, we stretch it into the shape of a cup. So we take this flat sheet of steel and we push a die down through the middle here, into that flat sheet, and we draw it into a cup. And actually, it'll be closed at this end. We'll actually punch that out at the end. It's going to stretch that steel. So we're changing the thickness of the steel. So it starts out at a certain thickness, and when we stretch it, it's actually going to be thinner. There's no machining on this part. So once we draw it into that shape, which is done on a high-speed press, multiple stations, anywhere from 8 to 10 different stations to draw it to that shape. Once we do that, that cup is not going to be ground or machined or anything. It's going to be heat treated still. It's going to be cleaned and heat treated, but it's not going to be ground or machined. Again, made on a high volume press, so that helps us a lot with the cost. Now, this material, for us to be able to stretch it, we can't use 52100. We can't use a high carbon steel. So we use a low carbon steel to make this cup. Now, what we do to make sure that it's still hard, like we do with other low carbon steel, is we case carburize it during heat treat, which means that we put it through heat treat and we introduce carbon and a carbon atmosphere during that heat treat process. And that makes that surface hard enough for those rollers to ride on. Now, what are the rollers made out of? Just like all rolling elements, 52100 steel. So all of the rolling elements that we're going to talk about, whether it be a needle, a ball, spherical, cylindrical, tapered roller, all are going to be made out of 52100 steel. Now the cage, if there is a cage inside there, is typically going to be made from a low carbon steel. Again, that's also going to be carburized and heat treated. So one of the questions that I always get is, why do we call them needle rollers? So why don't we call them cylindrical rollers? Because they're kind of like a cylinder. So a needle roller is basically an elongated cylindrical roller bearing. So a cylindrical roller. So we take a roller, and when it gets to be 4 times as long as it is wide or diameter, so as the length exceeds 4 times the diameter, it becomes a needle. Now, my needle bearing engineers will also correct me, because they seem to think that we can make a roller or a needle roller that's 1 inch or the same size, same diameter as the same length. What distinguishes a needle roller from a cylindrical roller is the fact that we don't grind the ends of those rollers. And why is that important? Well, if you grind the ends of those rollers, then they'll be capable of taking some thrust load. Needle roller bearings cannot take any thrust load, and the reason is because we do not machine the ends of those rollers or the insides of the race where that roller is being guided. So when we look at drawn cup needle roller bearings, we have 2 types. We usually break it down to 2 types. One is the cage type, or the full complement type, which is just a full complement of rollers. There's no cage in here. So how do we hold those rollers in? If you look really close, you'll see there's a trunnion on the end on each end of the rollers. A trunnion is just like a rolling pin. So it's like got a smaller handle there. Well, that trunnion will fit into the edge of this cup here. So it gets captured by this cup being curled over on both sides. And that's what holds the full complement needle rollers inside the bearing. Now, the other type of product is what we call a cage product. Now, those rollers are flat-ended. And so what holds those rollers in is the cage. So the cage and roller, the cage retains those rollers inside the bearing. And you can see the cage and the flat-ended rollers. Now, What's the big difference between a full complement and the cage version? Well, one, because this has more rollers than the cage version, it's going to be able to take more load. So because there's no cage in between, you can carry a lot more rollers. Well, but the problem is with all these rollers are rubbing up against each other. So when those rollers rub up against each other, that creates a tremendous amount of friction. So that's the purpose of the cage, is to separate those rolling elements so it doesn't generate as much friction. So a caged product can go a lot faster, but it can't carry the same amount of load as the full complement. So a full complement can still have some sort of speed rating, but the cage version can go much faster. But this can obviously carry a lot more load because of the number of rollers. So the size range for these are anywhere from 1/8 of an inch bore. So we're talking a very tiny bearing, all the way up to 5 1/4 inch or 5 1/2 inch bore. On the metric side, we go from a 3 millimeter bore all the way up to about 50 millimeter bore. So we can make the product a little bit bigger in inches than we can in the metric product. Now, what are some other features on a drawn cup needle roller bearing? Well, you can get a closed end. A closed end, we would actually close off the end of one side. Why would you want to do that? Well, if the shaft ends in the bearing, it's a great way to seal this bearing. Now this bearing is sealed if it's closed-ended on one end. What we also do is we can put an oil hole in the OD of the bearing, and that allows you to lubricate the bearing through the housing with a cross-drilled hole, and that'll feed oil or grease into the bearing. Now you can get these bearings sealed, so you can get them sealed, but you can't get the full complement bearings, the ones without the cage. You have to have a caged product to be able to seal it. See, with the full complement, there's no place to put a seal. There's no place to drop a seal in between those rollers, because the rollers go all the way to that curled lip. In a cage product, what we'll do is we'll actually end up making the cage a little narrower, and that leaves a gap between the cage and this lip, and that allows us to put a seal inside there. Now, both of these we can actually pre-lubricate, so we can put grease on these and ship them that way. So they can come with grease in them, or a lot of times they'll just come with a rust preventative. Now, as you notice, there is no inner ring. There's no integral inner ring. So what that means is you would have to mount this directly on the shaft, and the rollers would be in contact with the shaft. Now, if the rollers are in contact with the shaft, that means that the shaft would have to be machined and ground. It's going to have as smooth a surface as the bearing races. And it's also going to have to be heat treated and hard. So it's got to be the same hardness as if it were a bearing itself. Now, if you can't do all that, then you can purchase the inner ring. There's an inner ring that will go with this, a matching inner ring that will go with the drawn cup needle roller bearing. And for every drawn cup that we have, every catalog size, we also have an inner ring that will go with it. So if you can't machine and grind your shaft and heat treat it, then you can get that inner ring that goes along with it. Now, when you get this part out of the box, when you get the finished part, it is not round. So when you pull this part out of the box, if I go to measure the OD of this part in several places, you will find that this part is out of round. And you're like, well, wait a second, why is the part not round? Don't we want perfect circles? Don't we want round parts? Yes, we do. What happens is because the shell or this cup is so thin, when we put it through heat treat, it kind of distorts. It twists a little bit. And so what we have to do is, what the customer has to do is press this drawn cup into a hole, into the housing. When we press it into the housing, that cup will form inside that housing bore. So it's going to take the shape of that housing bore. So these drawn cups are always going to be what's called a press fit into the housing, which means that the bore of that housing is going to be smaller than the OD of this part. So this part will not just go in. You're going to have to force it in. And when we force it in, we actually kind of round up the part. And that part is going to be just as round as that housing is. So that's how, and the nice thing about that is that it stays in the hole then. So that part will not have to need a snap ring or a shoulder to place it. Once it's pressed into that housing, that will position the bearing where it needs to be. Now, when you are pressing on the bearing, you will see by this part here that there's a part number on the face of the bearing. So that part number is what we call the stamped face. When you go to install that bearing, you're going to want to push on that stamped face, the part with the part number. The reason is because this face has been hardened. This side is going to be softer, and you might risk cracking this lip. so you might risk cracking the lip if you press it from the wrong side. So drawn cup needle roller bearings, you're going to want to press to push it into the housing. You're going to want to push on that stamp side. So why use a drawn cup needle roller bearing? The drawn cup needle roller bearing, it's great for high loads. It's got a great thin cross section for high radial loads. So when I talk about full complement, which is a full complement of rollers, drawn cup needle roller bearings, I consider them the best bearing for, it gets the most amount of load, most amount of radial load per the amount of real estate that it's got to take up, right? So it takes up the least amount of real estate, but can take the highest radial loads. So it's great for putting into really thin cross-section areas. So used in devices with really tight spaces. Now, again, needle rollers, no thrust loading. So we can't put any thrust load on this part. We can only put a radial load. Okay? They're inexpensive. Why? Because they're made on high volume presses. So we're going to be pumping these things out, 1,000 pieces an hour on these high-speed presses. So as long as it's a standard size that we're already tooled up for, we can make these parts in high volume. There's not much material used either. So high volume, little material translates to a low-cost product. Installation, again, is simple. Again, once we press it in, we don't have to position that bearing with a snap ring or a shoulder. We can just press it into that housing and it's ready to go. So where are drawn cup needle roller bearings used? Well, they're originally designed for automotive engines and transmissions to replace bushings. So bushings, they generate a lot of heat, they generate a lot of friction because there's a lot of contact. So by putting in a drawn cup needle bearing, we can dramatically reduce the amount of heat and energy. And so for automotive applications, that would translate into better fuel mileage. So during the 70s, when we had the oil embargoes and the OPEC was created, obviously gas prices went very high, and so the automakers were trying to find ways to reduce or to increase fuel efficiency, right? So to do that, they replaced all of these bushings that were all throughout the engine and different parts of the automobile and replaced them with drawn cup needle bearings. So that was the big push. So obviously, they're also in auto hub assemblies. So these bigger, thicker drawn cup bearings, we call this a thick walled drawn cup with big, thick rollers. So these would go actually in your rear wheel hubs. I said, wait a second, Pat, I thought that these couldn't take any thrust load. Well, they can't. So does that mean that we can't drive a car around a turn? No, what happens is these are only designed into special axles, where not special, but axles that have a differential in them. And that differential has a tapered roller bearing set in it. So we have a different set of bearings that are going to take the axial load. These deep groove drawn cup bearings are going to take the majority of the radial load. So where else are they used? Compressors, pumps, motors, hydraulic pumps, fractional horsepower electric motors, and gearboxes. A lot of consumer products, such as printers, ATVs and snowmobiles, transmissions, power tools, paint sprayers, exercise equipment. So all kinds of applications that require very tight spaces. So if you want to miniaturize something and you have a high radial load, the best way to do that is with a drawn cup needle roller bearing. So in summary, drawn cup needle roller bearings, a very good power dense bearing solution for high radial loads. High radial capacity versus that thin cross section.
I hope you enjoyed our overview of drawn cup needle roller bearings. Stay tuned for more bearing training from JTech, formerly known as Koyo.